Welcome to Mind and Machine, where we explore the science and technology of human performance enhancement. I'm August Bradley. My guest today is Dr. Christof Koch, one of the world's foremost experts on neuroscience and consciousness. Dr. Koch is the chief scientist and president of the Allen Institute for Brain Science. He recently released his latest book, The Feeling of Life Itself: Why Consciousness is Everywhere but Can't Be Computed. It explores new insights and perspectives into human consciousness, as well as ideas surrounding the potential of sentient machines. Dr. Koch's primary collaborator in research on the neural correlates of consciousness was Nobel Prize winner Francis Crick, starting with their first paper together in 1990 through their last that Francis Crick edited the day of his death in 2004. Since then, Dr. Koch has been one of the most pioneering thinkers and highly cited researchers in the field. We explore a wide range of issues surrounding consciousness, what it means, and the theories on how it works. If you're inspired by these topics, consider subscribing to the free Mind and Machine newsletter at mindandmachine.io or at the link in the show notes. And please spread the word about the Mind and Machine podcast and YouTube show. The key to success and sustainability for us is word of mouth from listeners and viewers. I want to enhance our future by sharing essential insights on transformational changes and bringing more people into the conversation. We all need to be a part of shaping this future. Send anyone you think might be interested to mindandmachine.io. Subscribing to the podcast and our YouTube channel helps build the show and our collective future. Now, let's dive in. Christof, welcome to the show. Thank you for joining us.
Thank you for having me, August.
So I am fascinated by your work across so many aspects of consciousness and neuroscience. Let's just start by trying to get a sense and bring everyone up to speed on what is consciousness and how it uses and is distinguished from intelligence.
Yeah, so consciousness in general, it has diverse meanings, but most people, most philosophers and scholars today would consider consciousness to be any experience. It feels like something to be me. It feels like something to be angry. It feels like something to see. I have a picture of you in front of me. I have this voice inside my head. I can feel in love. I can feel upset. I can know that I'm a man. I'm going to die one day. Those are all different conscious states. And the central mystery around consciousness, which is really the beating heart of the mind-body problem, is how does consciousness get into the world? Because if you look at the foundational equation of physics, general relativity or quantum mechanics, if you look at the periodic table of chemistry, if you look at the endless ATGC chatter of our genes, nowhere is there anything about experience, about consciousness. Yet here we are experiencing the world. We come from nothing. This morning when I woke up, I wasn't there, and suddenly I was there. And, the alarm rang and my dog was there. And then tonight, presumably, I'm going to eventually disappear again. Me, the Christof, will just be gone. And then, I'll wake up inside my sleeping body and have experiences, and I call those dreams. And then they disappear again. And then again, I wake up and there I am again. So where does this come from? And this is really very different from intelligence, although in people or in general in biological creatures, those things are related. But intelligence is really the ability to rapidly take an input, process it, and provide an output. Short-term, immediate, or medium-term, long-term. Planning, thinking about the world, thinking about the action, the underlying causal agents, what I should do in response to this, that, or the other. That's intelligence, and we have it, and other animals have it. And so far, we've been living in an era of biology where if you wanted intelligence, you always got consciousness, right? If you wanted somebody who did your taxes, which requires intelligence, or to dig a ditch that requires intelligence, or to fight a war, you got people and they were also conscious. But in principle, at least conceptually, you can sort of put them on two different axes. One, you sort of plot intelligence and an increase. On the other axis, you plot sort of how conscious anybody is, and it increases. In principle, at least, you can imagine that it's not only populated along the diagonal, where it is by evolution. In other words, evolution has given rise to creatures. They become more and more adaptive, more and more intelligent. Their brain sizes becomes larger and larger, and then they become more and more conscious. But you can also imagine other systems that we might be able to build, to engineer, that are either have high consciousness and very little intelligence, or high intelligence but no experience of themselves or of the world.
And I love how your new book, which is very new, a few months old, poetically articulates that. The title is The Feeling of Life Itself, and I think that kind of beautifully sums it up.
Yeah, that's a central mystery. I mean, I feel like something. Being alive feels like something. And where do these feelings come from? What part of our body? We now know, unlike the ancients, they don't relate to our heart. You know, when I say I love you with all my heart, I don't really love you with my heart. I love you with my hypothalamus or my cortex, etc., although it doesn't sound quite as romantic. But so today we know it's in here. It's the brain that gives rise to conscious experience. And one of those experiences is the feeling of just being simply alive.
Is consciousness a property of physical systems? Does it emerge from chemistry and physics, or is it something altogether different?
Okay, so we used to think we needed a soul, right? So the classical dualism that's still embodied in, let's say, a Roman Catholic thought or Christian thought that dates sort of to René Descartes or even all the way to Plato is really there's the brain, and it has certain properties. But then in addition, there's this additional thing called a soul. Now, we don't think like that anymore. Most scholars and certainly all scientists don't think like that anymore. It hasn't served us very well. What has served us very well to assume that everything is a consequence, including our thoughts and our conscious experience and our memories, is an ineluctable consequence of the causal powers of the brain. And so it's somehow consciousness emerges out of physics and chemistry and biology. That's what all the empirical evidence suggests. And in fact, I can manipulate consciousness by manipulating, you know, the substrate, right? I can take the brain, I can inject it with electrical current, like doing a neurosurgery, or I can apply outside magnetic fields or electric fields. I can take drugs. All of those act on the brain, and they change our conscious experience. When we have holes in our brain because, you know, of a stroke or a virus or gunshot or something, again, we can miss specific classes of conscious experience. So we know there's a very tight relationship between the physical organ of the brain. Let me show you one. And I have this facsimile. It's a plastic copy of the brain. It's a copy of an actual brain. So, you know, it sits inside the skull. It looks smaller to most people than they think because, of course, we never see the brain. We only see the skull, right? But this is a typical brain. And somehow this 3-pound substance, which is the most complex piece of highly active matter in the known universe, gives rise to consciousness. And so what scientists, like brain scientists like me or psychologists are trying to understand, is it the entire brain? Or is it part of the brain? It looks like it's a particular part of the brain. And what is the relationship between the activity in part of this brain and consciousness? Can I pick that up using EEG or other tools? What happens in people? Can I build tools to monitor the presence of consciousness in severely disabled patients, like persistent vegetative state? You might remember the name of Terry Schiavo. You know, she was a patient. She was for 14 years in a persistent vegetative state. And then there was this there was this big debate that involved at the time the courts and went all the way up to then President George Bush. Did she have a right to die? Was there anybody still home in her in this heavily damaged brain?
Right, there was a debate between different family members over whether they should pull the plug or not, right?
That's correct. It was between the husband, or at that time the ex-husband, who said that she had said before she had this the anoxia, the episode, that she didn't want to live in this state, and her parents, who were devout Christians, and so there was a big fight about it. And there are thousands of patients like that today in various hospitals and hospitals and homes, where it's really very difficult to say whether they're conscious. They're clearly alive. They may have periods when their eyes are open. You know, they may be, you know, like this, and occasionally they move or they groan. Their eyes may occasionally open, but no evidence of purposeful, voluntary, willful behavior. So it's a big dilemma. Is there anybody home, or is it just sort of brainstem reflexes? Then, you know, at the beginning of life, when does consciousness actually start? Which is different from the question, when does life occur? Because those things are different. Then there's a question around brain death. You know, there was big report in the news half a year ago about a pig brain that could be revived after 4 hours. To what extent is there still consciousness present? So there are all these scientific problems or clinical problems to ask. Then the other question is, how low does consciousness go? Most biologists assume we share it with most mammals, cats and dogs and monkeys. That's not to say that my dog has a voice inside his head and, he knows it's weekend and things are different. But, my dog clearly has, as clear as I can say to anybody else, he seems to be happy and sad and depressed and fearful and angry. And if I study the brain of dogs or cats or monkeys and mouse, if I take a little bit of quinoa grain size brain and compare it with a human, it's very difficult to tell the difference. The basic hardware is the same. Our brain is bigger, but of course the brains of whales is even bigger. The basic substance is very similar. But what about outside mammals? What about birds? What about squids, octopus? What about bees?
Or insects when you get tiny? Yeah.
Insects, worms. How low does it go? What about a protozoa? What about a bacteria? What about things that aren't even alive anymore? Is it possible that certain types of physical systems, complex physical systems, all the way down to brute matter, feel like something? So those are all questions that ultimately we would like to address as scientists and as people. We'd like to know what else is in the universe. Is it just us and closely related species, or is it more thing? And then, of course, there's a big question of the 21st century. Can we create consciousness?
Right.
Either in a dish by building artificial brains, so-called cerebral organoids, or brain in a dish. You take some cells from under my arm, you put them in a dish, you add some transcription factor. So now you've got inducible pluripotent human stem cells. You guide them down a developmental pathway that takes you maybe 9 months to a year. So they turn into forebrain neurons carrying my DNA or your DNA or the DNA of the patient. And after a while, they begin to show some electrical activity. And so there you can ask, well, if now you get sort of electrical activity similar to that of a preterm infant, for instance, will it feel like something? And then, of course, on the other hand, can we engineer conscious creatures in silicon and in software?
Right. It seems like the working premise in Silicon Valley, and certainly speculation in science fiction, is with enough intelligence and enough power and enough complexity, consciousness will just emerge in some way. Is that plausible, or is that really just sci-fi?
Well, it depends. So here, there's a big distinction between what you believe consciousness is. In principle, there's nothing. The vast majority of philosophers and most scientists agree there's nothing magical about the human brain. It's a piece of the furniture of the universe, has to obey the same laws that everybody else has. So there isn't anything supernatural in our brain. So because the brain fundamentally is a piece of physics, if I can replicate that piece of physics in a different medium, I should be able to recreate its properties. Okay. So most people agree on that. But then there's a division. There's some people who say, well, ultimately, consciousness is all about behavior. It's ultimately about replicating behavior in humans that associated with speech, with memory, with planning, and with things like that. And if I replicate those in a sophisticated machine, let's see Alexa 20.0 in 20 years from now, then Alexa will not only be smart, she will not only be able to have an effortless conversation with me, but she'll feel like something. In fact, you can ask her today. Try it. If you have Alexa, ask her.
She'll tell you.
Okay. She'll tell you. So that's one approach. Ultimately, it's behavior. If I mimic all the behaviors, in addition to the cognitive modules that we have, in particular language, planning, memory, short-term and long-term memory, then I'll get consciousness for free as it will emerge. Or there's a different school that says, well, no, ultimately consciousness is not so much about, it can't be computed. It's not a clever hacker way, that consciousness is not a computation, that ultimately you have to build consciousness into the physics of your system that you're trying to emulate. So if you're trying to emulate a brain, you have to build what's called neuromorphic hardware. You have to build hardware that, just like the brain gets, where a single transistor or single gate gets input from 50,000 other transistors rather than 3 and 4 on a typical ALU, where it projects to 10,000, 100,000 other transistors simultaneously, massive parallel architecture at the level of the metal with huge overlap. Otherwise, you're just going to get behavior, but no consciousness. It'll be all fake.
So basically, you'll get simulation if you don't have that architecture.
Correct. So the claim is, in particular, the claim of, so there are sort of two dominant scientific theories of consciousness around right now. One is called integrated information theory. The other one is global neuronal workspace. An integrated information theory, abbreviated IIT, ultimately says consciousness is about intrinsic causal power. It's about a system that's so complex. It's massively influenced by its past and by its future. It can influence its own future. And any system, any physical system, whether it's evolved or not, that has causal power is conscious to at least to a certain extent. The more intrinsic causal power you have, the more conscious you are. But it can't be simulated. You actually have to build it into the system. Just like you can simulate gravity, but you're not going to get a black hole. So I have a friend at Caltech. She's an astrophysicist. She can simulate Einstein fields equation on a laptop that simulates the massive star at the heart of our galaxy, at the center of our galaxy, and it turns out it's a black hole. It's so massive it twists space-time around it. Okay, so nothing, not even light or of any wavelength, can escape from its surface. But funny enough, she doesn't get sucked into her simulation, right? the space-time doesn't twist around her laptop. It doesn't suck her up. It doesn't suck up the room. Well, why not? That's a difference between the real and the simulated. You can simulate things like gravity, like behavior, but that doesn't mean you have the causal power of gravity to bend space-time, or that you have the causal power that you need to be conscious.
When you talk about causal power, are you talking about physical influence, or causal in the way that ideas or memories could influence something?
No, it's causal. Ultimately, it's a physical theory. It says ultimately what exists is only causal power. Causal power on each other, like, in gravity, one mass exerts causal power on another, or charge, electric charge attracts or repels other charges, or the system has causal power upon itself. Its past determines its future, and its present, and its present influences its future. The more sophisticated the system is, in a very specific way, this quantity can actually be computed, the more conscious it is. So it's sort of a physical theory. Ultimately, it says conscious is something very fundamental. It didn't emerge out of matter. In some sense, it's present all along. That complex systems, to a larger or smaller extent, feel like something. That's ultimately what consciousness is. And this goes hand in hand with a very ancient belief that's widely accepted in the East, that's has been present in the West throughout its last 3,000 years, called panpsychism. Right? Pan, everywhere, psyche, soul, that everything is sort of in soul to a certain extent.
Yeah, I want to get in that deeper, but while we're on the point of the neuromorphic computers being, in your view, a necessary prerequisite for conscious machines, does that mean these neuromorphic machines would need to have some analog qualities? It cannot be just digital?
That's a good question. I mean, it really depends on the details. You really have to look, the theory is complex. You really have to look at the actual physical mechanism that's implemented by, either analog hardware or digital hardware. Also, for example, you have to look at, quantum machines. To what extent can, Google's quantum computer, for instance, or IBM's, to what extent can they instantiate more intrinsic causal power than a classical machines? That really depends on the detail. The brain, of course, is analog and digital. It's sort of a hybrid, asynchronous, non-clocked machine.
And the causal properties come from the physical side?
Oh, yeah, entirely. You have a particular mechanism, a bunch of neurons where some neurons are on or some neurons are off, or a bunch of transistor gates where some channels are off and some are on. That every physical system will exert some causal powers on others and on itself. And in principle, if you get what's technically called the transition probability matrix, I can compute that. So in principle, at least, these are computable quantities. It's entirely, that's what I mean. It's a natural theory. It doesn't evoke some supernatural, spooky things that in principle, that physics can't measure.
Okay.
A global neuronal workspace, the other competing theory says the opposite. It says, no, ultimately, it's all about computation. That if I have the right processor, it's powerful enough to mimic human particular capability, And certainly if I were to simulate a human at the right level, I would not only get human level behavior, including intelligence, but I would automatically, as a side effect, sort of get human level consciousness.
From digital only processes?
From software.
Okay, software. So that doesn't,
yes.
So there's no causal
running
element
on
in
a
that.
digital phenomenon machine, yes.
So global workspace theory is not dependent on the causal quality.
No, it doesn't make any claims. It doesn't make any claims about causal. In fact, it's sort of, it's one of the modern trends. There's a number of philosophers that continue to deny that consciousness really is anything special above and beyond the physical properties that we know of. That when people talk about, it feels like something to be me. Some philosophers like Dan Dennett say, I have no idea what you're talking about. You're really confabulation. There really isn't anything what it means. It feels like something. All this qualia stuff, he said in a well-known interview in the New Yorker, that's all balderdash.
Okay, so
I happen to totally disagree with that, but so be it.
Right. So my understanding is you fall much more heavily on the integrated information theory. And what is it that pulls you in that direction, if I'm characterizing that correctly?
Well, so several reasons. So my basic intuition, which is really the most famous deduction in Western thought, cogito ergo sum, right? That's really the fundamental thing that I can be certain of. So Descartes, 450 years ago, asked himself, what is it that I know for certain? What is it that cannot be doubted? He said, well, there could be an evil deceiver that makes me deceive that I look the way I look. Today we would say, maybe I'm living in a simulation. And he says, but the one thing that cannot be doubted, that I exist because I think, I feel, I cognitate, I think, I remember. He goes on in a long list. Because of that, I exist. The content, what I think or what I feel, can be mistaken. But that I exist because I feel, that's the only thing I know. That's sort of bedrock certainty. And for me, it always comes back to that. The only thing I know when you have a toothache, you have this god-awful toothache and you try to distract yourself, but it doesn't work. And you wonder, why does it hurt? Ultimately, there's this bedrock you hit of ultimately there's an experience. And you can't go and sort of below that. Your conceptual spade work has hit the underlying bedrock. And denying that, saying, well, Christof, you're really confused. You're confabulating. There really isn't anything like what it is to be in pain. That's just balderdash. That's obviously at this point when I'm in pain, it's the single most real aspect of the world. And so everything else I know about the world, that you exist, that you're an independent person, that you're conscious, all of that I infer. I don't actually know, right? That's the thing with consciousness. That what makes it more difficult to study than, let's say, black holes or viruses or proteins or neurons, because they have what's called third-person properties. Consciousness has a first-person properties. It feels like something to be me. Presumably, it feels like something to be you, August, but I don't directly know that. I can only ask you, which of course is indirectly, because you might be lying to me, right, about what you really feel, or if you feel something at all. Like I believe Alexa is lying if she tells me she's conscious.
Knowing the similarity of the systems that our own consciousness has emerged from, and seeing the similarity in others, we can probably infer, probably safely, that others have
entirely
consciousness.
Correct.
But the more different a system gets, the harder it is to make that inference, I suspect.
That's 100% correct, yeah. So this process that you refer to is abduction. So I abduce that you're conscious because your brain is so similar to mine. Evolutionary, we're very closely related. Our behavior is very similar. Therefore, I assume that you and everybody else around me is conscious. And then we make the same abductive step with babies, although they can't talk, with dogs and cats and other animals, and certainly other mammals, because evolutionary, they're very similar. They don't talk, but, they can tell you their emotion, the way their dog, they bark and the tail waves and the eye moves and the ears point, etc. But as you point out, as it gets more and more different, like a squid, it's very different. It doesn't have has 8 arms. It's squishy. It lives in the water. It doesn't have a tail that it wags. It becomes more difficult. With the bacteria, it's very different. And with the computer, it's radically different. So that's why ultimately we need a theory that tells us, not just sort of based on my intuitions, but a theory that tells us fundamentally which systems are and which systems do not feel like anything. In the end, for most people, that may not matter, theory. To most people, particularly if we look forward into the sort of more distant future, i.e. 50 years from now, once we are surrounded by the helpful siren voices of, Siri and Cortana and Alexa and everything else, we have this attribution thing. We attribute, agency and consciousness to all sorts of things, to cars and we do it automatically, intuitively. Of course, we're going to attribute consciousness to machines, whether they actually are conscious and are capable of feeling anything or not. But it's going to happen sooner or later.
And that has the potential to say something about ourselves, how we treat machines that we perceive as conscious, regardless of whether or not they are. Imagine that's rife with ethical issues.
Correct. But of course, the history of mankind has shown, the bloody history of 20th century humanity has shown that even we perfectly well know those other people are like us and they do have conscious experience, so we're still willing to kill and maim and torture them.
That's a sad truth.
Yes, but ultimately, of course, that should influence how we treat machines, because ultimately what matters is the ability to experience pain, among others. And to the extent that other subjects, like dogs, for instance, are capable of experiencing pain, we accord them some protection.
Right.
And so the question with computers is, well, if they're just sophisticated, but they never feel anything, then they're just an object like anything else. But if they're capable of experiencing something, then they become a subject, and then they are no more just a means to an end, but then in Kant's word, they become an end in themselves.
Yeah, and that gets into the whole Westworld scenario. Now, you've written and spoken about how many smaller systems can have some form of consciousness, and then when they're combined, they create an integrated consciousness. But when they combine, they don't each have their own individual consciousnesses, but there's sort of an integrated unit that maximizes all the consciousnesses together. How does that work within the confines of the integration theory?
Yeah, that's correct. Well, so integrated information theory says the only thing that exists for itself that's conscious is the maximum of integrated information. So let's take an example. This could be done certainly in mice very soon. Let's take your brain and my brain. You're conscious because your brain has a local maximum of integrated information. I'm conscious because my brain has a maximum of... Now we interact, right? You ask a question, I answer. There's some causal interaction. However, because the speed and the causal interaction is very crude compared to the massive interaction in my brain, your brain, it doesn't really change anything about that. Now, let's say we begin to add direct wires from my brain to your brain, right? So I have this future brain-machine interface technology, brain bridging, that allows me to bridge brains. There's actually a real-life example of this, 2 twins in Canada that are born conjoined at the level of their thalamus. So they're born with the 2 heads grown together, and they have fibers going from one brain to the other brain. Right? Wow. So let's say early on, these wires go between my visual cortex at the back of my brain to your visual cortex at the back of your brain. And then what I see early on is going to be a little bit like augmented reality. I see what I see, but then ghostly superimpose, I can also see what you see. But I'm still me, and you're still you. You're still August, I'm still Christof. But now the theory says, as we increase the bandwidth of these wires, as we add more and more wires between more and more neurons between you and my brain, at some point, this new system that consists of you, me, and all the wires in between will have a higher causal power, intrinsic causal power, will have higher phi, that's the Greek, the symbol for integrated information, than either your brain or my brain. At that point, abruptly, you, August, will disappear, you'll die. Phenomenologically, it feels like you just flick out, I flick out, and a new entity will appear, a new sort of August Christof, a new Ubermind that has access now to 4 cortical hemispheres, to 4 eyes, to 4 ears, to 2 mouths and 2 tongues, etc. It's a little bit like an inverse split brain experiment. You may have heard that this rare surgery that's required when people have heavy epileptic seizure, and to prevent the seizure from spreading from one brain into the other, they cut what's called the corpus callosum. So there are 200 million fibers that link the left and the right cortical hemisphere. So there are all these fibers that go between the two, and you cut them surgically with a knife, and then you sever. Now you have 2 cortical hemispheres. And as far as we can tell, there are 2 conscious entities in this single skull. only one typically talks, in the left hemisphere, but there are two conscious entities. And again, it's conceptually the inverse of this sort of thought experiment I was talking about. It's a little bit like the Borg. Remember the Borg from the Star Trek universe?
Yeah. So with the split brain, though, I just want to make sure the audience understands, because this is incredibly fascinating. So in the case, patients who have had this split, this central connectors severed, and actually separates the two lobes of the brain, there'll be two perceptions. In one side, the left, I believe, can speak. So that's the part that interacts. But the right brain would control the left hand. Is that right? And sometimes you'll have the left hand disagreeing, the mind on the right disagreeing with the mind on the left, and the left hand exerting that disagreement in sort of a fight between the two hands. It's just incredible.
Yeah, so this is called intermanual conflict, although typically that subsides within a few days after the operation. Somehow the left hemisphere, which, as you said, is a verbal dominant one, typically begins to dominate, and the patient will live, without these obvious conflict. But you can silence the left hemisphere, for instance, by injecting sodium amytal or some other quick-acting barbiturate, and then you can sort of just talk to the right hemisphere. Yeah, so as far as we can tell, there seems to be two separate consciousness.
Wow.
They may as well be on the dark side of the moon. Right? One consciousness does not have experience of the other one. They're two separate conscious, just like my consciousness is separate from your consciousness. And even though, if you take your spouse, you're married with her for 20 years, you make love, you're interpenetrated, you're still you and she's still her, and you don't, you can never directly experience what the other person will experience. In this sort of brain blending, you can, but at a loss of your own individual consciousness. And that's just like the Borg. So when Captain Picard gets absorbed by the Borg, right, then he loses his own identity. He's now part of this much larger conscious entity called the Borg. It's not that there's Captain Picard conscious and the Borg. So just like my individual neurons are not conscious, it's really the whole of my brain or particular parts of my brain that constitute the consciousness of Christof that makes up my conscious mind.
And is it that the level of connectivity between the different micro portions or the two lobes of the brain in that example, is it the level of complexity of the connection that distinguishes whether it sees itself as one being or two, one mind or two minds?
Yeah, so technically speaking, you have to compute this integrated information. How irreducible is the system? And you always have to look for the maximum. So this is a common principle in physics. Many principles in physics are formulated as extremum principles. And here it says the only thing that exists for itself, which is conscious, is the maximum of this integrated information. That's influenced by a variety of things: the strength of the connection, how many connections there are, the time scale of this connection, all that plays into it. And so for any particular physical mechanism, you actually have to look at the actual mechanistic detail to figure out where exactly the maximum of causal integration is. It's a scientific theory, for better or worse. That means you actually you can compute these things.
Is the primary evidence of the idea of combining different minds with enough complexity and interconnectivity, is the primary evidence of that becoming its own single consciousness based on the separating of two minds, sort of the reductionist
version? Yeah, we have
version?
no experience. We have absolutely no experience of multiple consciousness. I only ever in my entire life, and I would claim anybody's only experienced one consciousness. Yes, there are people who have multiple personalities, but that's very different. At any given point in time, they are one. And then, 5 minutes later, they get angry or scared or something and then switch to a different personality. But at that point in time, again, there's only one consciousness. I don't have a ghostly superimposition. I don't feel my left consciousness and my right consciousness, and then I can switch between them. No, I only feel, in fact, I don't know anything about my brain at all, right? That's why people early on believed it was all in the heart. I just have one mind. That's my conscious mind. And there are never two minds. I don't access ever your consciousness. I can infer what you think by looking at you, by seeing you blush, by doing reaction time, by listening to you, but that's all inferential. Direct experience I only ever have of one conscious mind. America, if you look at America, it's not that there are 310 million American, there's this one mind, which is America, and then there are 312 million individual, conscious Americans. No, there are only, as far as we can tell, 312 million individual Americans.
So we have potential various parts of our body, at least two, but potentially more, that if they weren't integrated, could have some form of consciousness on their own.
That's entirely correct. So, for instance, you have 50 or 100 million neurons that make up your enteric nervous system, your gut, right? Your second brain in your gut. When you feel disgust or nausea or fullness, we know it's a part of cortex here, and the insula, in fact, that's involved. But that's not to say that maybe when they dissociate, for example, when you have a radical vagal nerve disconnection, that it may feel a little bit like something to be your gut. But of course, your consciousness here doesn't directly know about it. So you would have to infer that somehow.
Wow. So you've also written about in the book the new efforts to measure consciousness, or at least to measure whether it exists or not. Maybe not so much degrees, but sort of a binary measurement, whether it's there. Can you elaborate on that in the zap and zip technique?
Yeah, so as I mentioned before, there are sort of two challenges to the clinical arts. One is in anesthesia. So, each day there are close to, 500,000 or so anesthesia being performed in the US and worldwide. And some fraction of those, maybe 1 out of 1,000 or so, for various reasons, these people wake up under anesthesia. And so what you really want, what we don't have, is a reliable tool that tells you for every type of anesthesia, is this patient that's currently right now being operated on and that's paralyzed. So in modern anesthesiological practice, you give a variety of agents. You give paralyzing agent, you give sedatives, you give agents that block the memory, right? And then you give agents that actually put them to sleep so they don't recall anything and they don't have any experiences. If that doesn't work, I need to know right now. Okay, we don't have such a reliable tool. B, as I mentioned before, there are thousands of patients that are due to gunshots, strokes, car accidents, falls, are severely neurological impaired, and they can be in a what's called a vegetative state or a minimal unresponsive, behaviorally unresponsive state, or they may be in a state called minimal conscious state where they are very severely impaired, but occasionally they can nod, or they can move their little finger and control something, or like Steve Hawkins, they can sort of move their cheek and control a laser that bounces off there. And so, but some of these patients you really don't know by behavioral measures. They don't look like there's anybody home. They don't respond purposefully. But then it turns out sometimes you can, for example, put them in a magnetic scanner, and some of them do have they can do very complex processing. So, again, evidence that they are conscious. So you want the technique that measures, again, for a particular patient, is this patient experiencing something? Is there anybody there? And so there's this technique that was derived that originally came from integrated information theory. It's essentially what it does, it puts a high density EEG electrode net onto the brain. Let's see, 64 EEG electrode or 256, and then pulses the brain like hitting a bell with a hammer. In this case, it pulses with a magnetic pulse called a transcranial magnetic stimulation, TMS. So that's the zap. You zap the brain. So essentially you hit the brain just like you hit a bell, and then you look at the electrical reverberation, right? And essentially you're listening to the complexity of those reverberations, just like you hit a bell with a hammer and you listen to the reverberation to see whether it's cracked to hear whether it's cracked or not. So here and then essentially you zip. Zip comes from the zipping, right, which is on our computers, which is a way to compress files. And this is called, after mathematician Lempel-Ziff, it's a compression algorithm. And it turns out the more you can compress the image of the EEG, the response of the brain, the simpler it gets, the more likely the patient is actually unconscious. In the extreme case, when they're in a deep coma and they have a flat line, isoelectric throughout the brain, of course, there is no signal, and so that's maximal compressible. And so you can derive this number called perturbation complexity index, and you can set a single threshold. And for every case people have looked at, whether that's volunteers that agree to undergo anesthesia, or that people that go from wake into deep sleep, or they're locked in patient that we know fully conscious, on the one, or people that go to sleep in deep sleep when they have no experiences, or when they do dream, So a single threshold just empirically looks like distinguishes all these people when they're conscious from when they're not conscious. And so this seems to be a very promising tool. It's still early days, but it's being investigated now in a variety of clinics to test, as a practical conscious meter. As you point out, it's very primitive. All it says in adults, hasn't been tested in children yet, in human adults, I can determine using this simple measure, is there anybody there? Is a brain complexity comparable to that of a conscious person or of a person who isn't conscious, who really isn't there anymore? And so now can we extend it to, all sorts of other cases like deep schizophrenic or catatonic or split brain patient or pediatric patient? And then can we extend it to monkeys? Can we extend it to mice and other creatures that have a cortex? So how general is this tool? And then can I derive a tool that measures continuously?
And that reverberation once again highlights the importance of that causal relationship. You're relying on that as part of
That's
the system.
Entirely correct. It's a causal manipulation.
Right. And that's the measurement.
Yeah, you're
from
essentially
that causal
doing
property.
this. You're hitting.
Right.
Sorry.
Right.
Oops. Out of the brain.
Hopefully you're not doing that. Knocking pieces out of the brain for those listening. You have made the statement that physics is looking as an outside observer. Consciousness is looking at physics from the inside. I thought that was really poetic and really a matter of perspective, sort of a third person versus first person perspective. Are some separating consciousness from intelligence, are some consciousnesses more narrow in their range of feelings or awareness, or is it sort of binary? You either have the light on or the light off?
Yes. In a sense, conceptually, so we have to distinguish practically and conceptually. Conceptually, the theory says any system that has intrinsic power upon itself is conscious. There's no threshold. This makes, in some sense, great deal of sense. There is no magical threshold 42. It's not like, well, if you're 42, more than 42, you're conscious. If it's less than 42, you're not conscious, right? It doesn't have this threshold. Practically speaking, though, we know when my brain goes into deep sleep, when you have these regular waves crisscrossing the brain at night, the delta waves, the deep sleep waves, it doesn't feel like anything to be me. Now, my brain doesn't dissolve into a soup. It's still there, but its causal effectiveness is greatly reduced. So I suspect that if you go to smaller and smaller animals with smaller and smaller brains, it may not feel a lot to be a worm. It may just feel like a little bit to be a worm the worm clearly feels like something, but it may be very, very minimal compared to when the worm is dissolved into its individual constituent particles, right? When it's dead, as it were. And so as the brain becomes more and more complex, the state of consciousness you have access to grows. And we know this in children, right? Or young babies. Young babies or children, they don't know about themselves. You ask them, why did they do something? They have no idea. It just popped into their mind, right? Early on, they can't reflect upon themselves. And then as their brain continues to mature, right, into the second or sometimes even third decade, right, also as an adult, you become more reflective. You become more self-conscious. You have a wider range of experience. Think when you first had sexual experience, right? That was something totally new. Right, and so then your consciousness keeps on growing when you educate yourself. When you become educated about art or music or something, you begin to make finer and finer distinctions. So it can grow, but of course at the end of the life, with dementia or other diseases, it can also go down again. So it's graded across a lifetime, across species,
right,
and most likely across individuals.
So it seems inevitable that even the differences among adults could be enough to really cause endless misunderstanding and conflict, just from the scope and range of our consciousnesses, separate from our intelligence and experience.
Yes, and we know this every day, whether it's, somebody who misunderstands me when I say, no, I didn't mean that at all. This is what I meant. But, and then, of course, in the political discourse, where it's really now, becoming threatening to to our and to our nation itself. Yeah, so the challenge of us is the challenge of human life is always to really explain my feelings and how do they differ from your feelings, and not take it for granted that you see things the same way I do, because you may or may not, depending on your upbringing and your genetic background.
Right, but a lot of that is knowledge and intelligence, and I guess the ability to empathize is part of what you're talking about.
No, empathy. It's feeling.
Empathy, yes.
Pathos. It's a feeling with you. A visceral. So I love dogs above almost all other creatures. I have a visceral feeling when I see a dog being abused. I really feel it very powerful. And you can feel it with your loved ones. You have it. When you see your spouse or your child suffer, you suffer with them. That's conscious experience. That's not just knowledge. Well, it's my child and it carries my genes and all of that. It's much more direct than that.
But it seems there are two things. There's the conscious interaction with the knowledge, and then separately the knowledge itself. Is that fair, or are they really the same thing? I mean, does knowledge get closer to the intelligence and the hard drive processing?
Yeah, I mean, the knowledge. Well, so what do you mean? And so let's talk about this. This example, you see a suffering person, let's say a child, okay? Mm-hmm. So you have empathy with that. Now, what do you mean by knowledge in that case?
Well, certainly your interaction with the knowledge is going to be based on your consciousness. But I'm thinking that if say you had an experience of similar suffering when you were young, and so it taps that awareness, but there's your interaction with it, then there's also the knowledge of it itself. I'm thinking in terms of a computer analogy, where the computer has data stored on a hard drive versus the processing chip. Perhaps I'm taking that analogy too far.
No, I mean, our memories, by knowledge in this case, you mean, I recall. But very often you may not even have to recall that, because very often these things are totally implicit.
Right.
Like, for example, when people are afraid of something, when they get conditioned, something bad happened to them in a parking garage, for the rest of their life, they might be anxious whenever they enter a parking garage. And they may not even know about it, right? Until somebody pointed out to them, because it's the memory may be implicit, so it may be explicit or it may be implicit. But August, you raise a good point, which is evolutionary. If this idea is true, what is the driver of high consciousness? So clearly, we are creatures, compared to other mammals or other animals that have much more consciousness about the world and about ourselves than other creatures. And why is that so? Evolutionary. And it's really what drives evolution ultimately are not feelings, but it's behavior, right? If I'm more likely to survive and leave descendants, I'm more likely, my genome will be more successful. So that's ultimately all about behavior. So consciousness does not directly drive selection. It drives it indirectly by people having, empathy with others and, group cohesion, and maybe it's driving behavior. It's like a spandrel, but consciousness does not directly drive. So in that strict sense, it doesn't have a function evolutionary. It's only indirectly that it has a function, that we know that complex systems like brains have high phi associated with it, and they get selected because they are more efficient at taking information, integrating it, fusing it, and giving rise to powerful decision making. But it's an indirect driver. It's not a direct driver.
I had read a theory, I think it was relatively new, perhaps not, that consciousness evolutionarily served the purpose of prioritizing this just immense amount of information we're taking in. Does that make sense to you?
Yeah, sort of. It's so Francis Crick. I worked with him for many years on consciousness. In fact, that's a portrait of Francis Crick.
That's fantastic.
The molecular biology who co-discovered DNA, and he and I worked and wrote for 14 years about consciousness. That one of the functions of consciousness may be what we call the executive summary, right? Suddenly if there's an earthquake here, I live in the Pacific Northwest, so just like in California, there's the ever-present danger of earthquakes. So then you very rapidly have to summarize, okay, where's the door, where big glass surfaces, where's the biggest danger come from, and then to make an immediate decision in a way that I haven't trained before. It's not that, I train, like most people, I don't train for this.
Right.
That sort of seems to be one of the function that consciousness is related for. But that's not to say that the feeling itself gets selected by evolution, because, as I said, that doesn't matter for my successful propagation of my genes. Only behavior matters.
Okay. And this next question gets into perhaps dangerous territory, but is it conceivable to remove negative conscious experiences, the idea of perhaps bitterness or resentment, things that just seem not constructive to modern life and cause a lot of problems? I mean, obviously it's dangerous who's choosing to remove what, but since consciousnesses can have different ranges, is it conceivable that we could shape them in the future in terms of what range of being
in
has?
fact, people are trying to do that for post-traumatic memories, right? There are various active therapies where you essentially want to either overlay, the two different ideas. One is, can you actually remove the underlying memory of, the horrific effect, the horrific crime or battlefield wound or whatever happened to you? Can we actually remove the memory? Or B, can I overlay another memory to make that less intense? So in both cases, you're trying to manipulate. Ultimately, it's all about feelings. Right? Ultimately, what matters to us is how I feel, whether I feel good or bad and whether I suffer. And so ultimately, one of the goals of science has to be to alleviate the suffering. And that may require eliminating certain very painful memories.
And would that be done through touching on the causal elements of the brain or the body? Or is this more psychology?
No, this is, it's probably both. So there's cognitive behavior therapy that for certain things, so don't go to places where you will evoke these traumatic memories, right? So, for example, would be cognitive behavioral therapy. But they may not be by themselves powerful enough for all cases, or they might not remove everything. So yes, like very often there might have to be a combination of both causal interventionist, drug-based or electrical stimulation or some other therapy, plus some version of sort of more cognitive behavioral therapy, like for insomnia or for depression or for other forms of mental diseases.
You're an avid outdoor sportsman, a rock climber and a rower, and you've said that those activities let you touch the root of being, which I thought was really beautiful and profound. Have you looked at the work in the discussion on flow state and how those kinds of activities are flow triggers that let us go into our most capable psychological states? Is that work that you've...
Yeah, I'm very interested. So there's a variety of conscious experiences, unusual conscious experiences that I'm very interested in. So one is, as you mentioned, the state of flow, which typically you can obtain when you're doing an aerobic activity, running, climbing, rowing, playing soccer, whatever, where if you do it long enough, you get into this sort of mode where you're highly conscious, right? You're not a zombie, you're highly conscious, but you're not conscious of self. But and typically those moments are associated with high performance, right? You just perform flawlessly. Typically, they require hundreds of hours of training, right? Whatever you do, you have to do it at a very high level relative to your, to your initial training state. Then you can do it effortless without much thought. And partly what happens there, you lose your self-consciousness. You're hyper aware of your environment. Let's say in soccer, where all the other players are, and rock climbing, you're aware of the wall, whatever. But you are so well rehearsed that you can just do the climbing moves sort of automatically without giving a thought. Or Zen and the art of sword fighting, right? It's another famous example where if you train for 20 years with these gigantic swords, you can sort of fight without thinking. And it seems to be a great, almost ecstatic experience when you have these, which is interesting for the fact that if you suppress your self-knowledge, your knowledge of sort of that voice inside that head, that voice that always nags, you're never good enough, you still have this letter to write, your girlfriend is upset at you, etc. Why should that suppression of that self-consciousness sort of give rise to these pleasurable feelings? It's not entirely clear. And of course, the moment you realize you have a flow, it ends, right? When you say to yourself, I'm in this state of flow, then it's end, because now you're aware of it. So that's one state. The other state is pure experience, which may relate to it, but it's different in the sense. So I got it in an immersion tank, right? When you go into a water tank and it's at body temperature and you float. Tibetan Buddhists achieve it by years of practice, where you're conscious, so you're not asleep, but you're not conscious of any content. So there are no images, there are no sounds, there are no sights, there's no touch, no fears, no more ego, no aspiration, but you're still conscious. And that by itself, again, seems to be a wonderful state.
Right.
Why that should be so is not entirely clear.
This has been fascinating and really literally mind-expanding. Where can people find more about your work and your ongoing research?
Well, they can read my book, The Consciousness, A Feeling of Life Itself, or they can go to my website, Christof Koch, that's Christof and then koch.com. They can download, I write frequent blogs, or I write for Scientific American about these topics for a general audience.
And the book is fantastic. I would highly recommend that.
Thank you.
So thank you so much, Christof. And thank you for tuning in. If you're watching on YouTube, leave thoughts or comments below. If you found value in the show, please like the video so it gets promoted in the algorithm. Subscribe to the YouTube channel and hit the bell so you don't miss the remarkable guest lineup we have in the pipeline. If you're listening to the podcast, ratings and reviews on iTunes or wherever you listen are massively helpful. They help us get promoted on those platforms. Be sure to subscribe to the newsletter to receive show updates, plus my newsletter essay and curated articles on transformational technologies. It comes out every 3 weeks. Everything's accessible at mindandmachine.io. Thanks. Until next time.